Okay, so step one for all of these problems, factor everything. So I'm going to factor the numerator, I'm going to factor the denominator when possible. Sometimes it's not going to be possible, but for this first one it is. So I'm going to get plus 5 minus 2 plus 5 minus 5. From here I would do my domain, okay, but there's no domain option here. So I'm just going to go to the next step. After you do your domain restrictions, you find the coordinate of a hole when there is one. In this case, there is, because that minus or that plus 5 cancels out. So there is a hole at x is negative 5. I just need to figure out what the y value of the hole is. So I'm going to take the equation without the hole, and I'm going to plug that x value in. So I'm doing negative 5 minus 2 over negative 5 minus 5. So negative 7 over negative 10. So 7 over 10. The negatives would cancel out. So the whole is at 7 over 10. Okay, that's not a negative. After you do the holes, the next step is to write the vertical asymptotes. These are based on the denominator. Note, a hole is not a vertical asymptote, so I'm not going to use the x plus 5 part for the vertical asymptote. I'm only going to use the x minus 5 part. So I'm setting that equal to 0. So my vertical asymptote is at 5. After we do that, we go to the horizontal asymptote, and that's coming from my powers, x squared over x squared. When those cancel out, you're just left with a 1. And then from there, I would go to my end behavior, but there's no option for end behavior on this. So then what's new is finding the y-intercept. So that's on my step 7 here. We find the y-intercept by plugging 0 in for all of the x's. You can do that in factored form. You can do that in factored form without the canceled factor, or you can do that in original form. Any form you want, you're going to get the y-intercept. So I do it in the original form just to keep consistency, but it doesn't really matter. So I'm just squaring everything. I end up with negative 10 over negative 25. And so the y value 0, or the x value 0, that's what I plugged in. And if I divide by 5, I get 2 fifths. So 0, 2 fifths. Another way we talked about doing this is you can type it in your calculator, and you can go to the table and you can get that y value from the table. X-intercepts happen by setting the numerator equal to 0. I should add a note here that holes aren't x-intercepts either. So in this case, I would set the factors in the numerator equal to 0. That x plus 5, though, was a hole, so it's not an x-intercept. I'm just going to set the x minus 2 part equal to 0. So 2, 0 would be my x-intercept. So that's all the new vocabulary from last week. For the next one, just starting right at the beginning, factoring everything. I'm going to take out an x. I would then do the domain, but there's no option for domain, okay? From there, I would do the whole, but there isn't one, okay? Actually, there is. We can cancel out the x, right? Those x's cancel out? So because those x's cancel out, we're actually going to have a whole at 0. All right, now what is the y value of that? We're going to go 3 over 0 minus 4, negative 3 fourths. Right, so I'm plugging that in. Once you're done finding the hole, then you do the vertical asymptote. Just side note, if it is a hole, then it's not a vertical asymptote. So the vertical asymptote is only coming from the minus 4. So x equals positive 4. in terms of my powers, I've got my 3x over my x squared, which really just becomes 3 over x. If you're ever left with a number over x, you have a horizontal asymptote of 0, which means you don't have a slant asymptote. Y-intercepts, plug 0 in for all of the x's. You end up with an error here because the denominator becomes 0, and so there is no y-intercept. The reason we get an error is because there's a hole there, right? And a hole's not going to exist, and so there's no y-intercept. X-intercepts happen by setting the numerator equal to 0, but the numerator equal to 0 was a hole. Holes aren't x-intercepts, so this would be another NA. And then finally, factor. From here, I would go to my domain. There's not a domain. After domain, I go to hole. There's not a hole. After hole, I go to vertical asymptote by setting that denominator equal to 0. From here, I would look at my slant. This one has a slant because the top is quadratic and the bottom's linear. Okay, so if I go to simplify, I end up with a linear equation. So I'm going to do synthetic division for this. Opposite of the bottom, coefficients of the first two terms. That last term's just going to give you the remainder. You don't graph a remainder. So I'm just doing the first two. So I'm going to have a slant asymptote at x minus 4, which would help me with my end behaviors, but that's not an option on this problem. Plugging 0 in for all of the x's, I end up with negative 3 over 2, or negative 1.5. Setting the numerator equal to 0, I actually have 2 of those now that there's not a hole, so I have 2 x-intercepts. 3, 0, and negative 1, 0. All the new vocabulary from last week's here. The only thing new we are going to do this week is add in old vocabulary. So nothing we talk about today is going to be a new word or anything like that. We are going to do stuff that we did in the last unit. So today we'll add in min and maxes, and we'll talk about tracing them in the calculator, which you already know how to do. Okay, we'll talk about increasing and decreasing intervals, like how to know when it's going up, how to know when it's going down, which you've already done before. We're going to freshen that up a little bit because I think some of you struggled with that on the last test. And then the worst of all, range. So we'll add in range today, and you'll see range of a few different graphs. Okay, we're going to do that same concept over the next few days for just different types of graphs. All right, so a lot of the graphs tend to look similar. There's I think there's 5 different kind of overall big idea graphs in here. So over the next few days, we'll bring those in and go over them. Your test for this unit is going to be on Friday. All right. So today we are going to do a full analysis of problems and then some practice in your workbook. All right. So the full analysis, it says toolkit full analysis. It's after the x and y intercepts in your toolkit. If you want to know what specific example, it looks like this. It takes up a pretty decent chunk of the page. And this is the first one. And I just have highlighted there, the only new stuff for today is what you see highlighted on the board. And it's not necessarily new, it's just new to this unit, okay? So we're gonna go through this, I have an 11-step process over here for these problems. So we're gonna start with factoring everything, and even though these are linear, they do have a GCF. So I'm going to divide out of negative 3, and I'm going to divide out of 4. after you factor everything, you want to find the restrictions from the denominator and write the domain. So based on this denominator, x cannot be -3. That's that factor in the bottom. If x is -3, the bottom's an error, okay? So if x can be -3, then our domain is everything except for -3. So I'm going from infinity to infinity, but pausing at -3. If there were 2 domain restrictions, there would be 3 intervals for your domain. The next thing I would do is cancel out any holes, right? So it would be factor, domain, holes. If anything canceled out, I would find my hole, but nothing cancels out here. So I'm just gonna write no holes. And then I'd go vertical asymptotes, because all of those things, the domain, the holes, and the vertical asymptotes are all coming from the same part of the equation, which is the denominator, okay? So in terms of my vertical asymptote, I'm gonna use this x plus 3, part of the denominator, and I'm gonna set it equal to 0. So my vertical asymptote is -3, which, if I'm graphing that, is a vertical line at -3, and it's dashed. So I believe you have a graph. You want to start practicing getting the pieces to the equations onto your graph. That's what a vertical asymptote looks like. After I do vertical asymptote, I usually go to horizontal asymptote. So I am looking at the -3x over the positive 4x part of the problem. And the x's cancel out, which leaves me with -3/4. So my y asymptote, my horizontal asymptote is -3/4, or you could write like -0.75 if you want. If you have a horizontal asymptote, you do not have a slant. So what that means for my graph is somewhere between 0 and -1. There is this horizontal line. The horizontal line also ties hand in hand with my end behavior. So if I have a horizontal asymptote of -3/4, I've got end behaviors of -3/4 too. From here, I'm going to do my y-intercept by plugging 0 in for all of the x's. -3 times 0 plus 6, 4 times 0 plus 12. So I end up with a y-intercept, which has a y value of 1/2. And that's a point on the graph between 0 and 1. So you can see that point in blue there. And then the x-intercept comes from when the numerator equals 0. Both of these things in blue, if you don't feel comfortable doing them by hand, you could use your calculator. We talked about on Friday how you can trace an x-intercept by doing a second trace 0. And you can find a y-intercept in the table. My x-intercept is 2. So now we filled out all the old stuff. For the new stuff, I highly recommend absolute min and absolute max, local min, local max, looking at the graphing calculator for those u's. So from here, what I'm going to do is type the equation into the calculator and hit graph and see if I'm getting any of those U shapes, whether it's upside down or not. I just need to pull up my calculator. So when you're typing these in your calculator, just make sure you're using the alpha y equals, so you're putting it in this form. So -3x plus 6 over 4x plus 12. That way I can get a picture of what the graph looks like. You're going to see a min and max if you've got a U or an upside down U, which I don't have that here. And so in the spot that says min and max, I'm just going to write NA. Because I don't have those. But I did get an overall idea of what my graph's going to look like, so I'm going to sketch that. Now that I can see that, right? Like that's what I saw in my calculator, so I'm just sketching that in. So no absolute mins and maxes. So increasing, decreasing is going to pair with your domain values, because we're using x values. So you're going to use your domain values, and sometimes you'll have to use your mins and maxes as well. But because we don't have any mins and maxes here, when we write our increasing and decreasing, we're going to use our domain intervals. So one of the intervals is going to be negative infinity to negative 3, and the other interval we're going to use is negative 3 to infinity. We just have to figure out what's happening. So when you are doing increasing and decreasing, you want to start at the far left-hand point of your graph and think about if you were walking on a path. Like if I was walking on this path, I would be going downhill. So from here to here, this is a decreasing interval because that black part of the diagram is like a downward hill. And that's negative infinity. Like this far left-hand side is negative infinity, and then it hits this x value, which is negative 3. So that decreasing interval is your first one, the negative infinity to negative 3. And that's a decrease. And then we're going to pick up where we left off, which is up here. And if I started my path there on the leftmost part and I was walking, I'd be walking down a hill. So from here over is another decreasing interval. This is negative 3 and this is infinity. So that negative 3 to 3 interval is another decrease. Nothing's happening at negative 3 though. So you can't say negative 3 to infinity. Nothing's happening at negative 3. Which means on this graph there are no increasing intervals. All right, and then the range.
I'm confused how you got like the end behavior.
Anytime you have a horizontal asymptote, you take it. So if it was 0, I put 0.
Okay.
Another way to do that, if that's confusing to you now that you have it in your calculator, is you could go to the table and pick like a really negative number. And you'll see it's leveling off at that same value.
Okay.
And same thing with the positive one. You could pick a really positive number.
Okay.
All right, so now we're looking at range. So to look at range, you're looking at the graph up and down. All right, so over here, I'm going to just kind of start at the bottom. Do you see how if I start here, there is black, right? Black is the actual graph. There's black all the way until this green part, and then at some point the black stops for a brief moment. So for your range, if you're looking from bottom to top, this is negative infinity, and then I have graph until I hit this part of my graph. This green line is where the black levels off and takes a quick break. That value is negative 3/4. Then it takes a quick break, and then you can see black picks up again right here. And then there is graph all the way up. It picks up again at negative 3/4. So it just took a break right between that line at 3/4. And then there's black all the way up the graph off of the grid, which is infinity. So my range is negative infinity to negative 3/4. It took a little break right at that green line, and then negative 3/4 to infinity. Your range comes from a few things. It comes from horizontal asymptotes sometimes, which in this case it does. It comes from min and maxes, and it comes from holes. So those 3 things will all impact your range. In this case, the only one of those 3 things that I had was a horizontal asymptote. There was no min or max to look at, and there was no hole to look at. So the purple there is up and down. All right, let's look at the next one. I'm going to go through the old stuff a little faster here. Okay, we've kind of been reviewing it all class. So factor first. I'm gonna take out a 4. As soon as I factor, I'll go right to my domain. Domain is what x can't be, and that's based on the denominator. Because there's 2 domain restrictions, there's 3 domain intervals. It's gotta take a break at -3, then it's gotta take another break at +3, and then it goes off to infinity.
So when it cancels out, it can't be a vertical, like, asymptote, or a vertical asymptote, but it can
It's
still
still a domain, yes, because it'll still be, and I'll show you when we do it, it'll still be an error in the table. That's why I always say, do the domain before you do the holes, do the holes before you do the asymptotes, because they kind of all carry a connection. So from here, there is a hole because that x plus 3 cancels out. So there is a hole at -3, the opposite of the cancel factor. So what do we have without that? We've got a 4 in the top and an x minus 3 in the bottom. So we get 4 over -6, or you can call that -2/3, or you can call that -0.67. However you want to look at it is fine. I don't care if you write a repeating decimal as a decimal. When you plot a hole, it's going to be an open circle in the graph. So at -3, -2/3-ish, there's just going to be this open graph. Factor, find restrictions, find holes. Find vertical asymptotes. Note, a hole's not a vertical asymptote. So even though the bottom has an x plus 3 and an x minus 3, the x plus 3 was taken care of already. So for the vertical asymptote, we're only going to use the minus 3. A hole is a dot on the graph, an asymptote is a line. Horizontal asymptote, 4x over x squared, 4 over x. Any number over x is a 0 asymptote. And if your asymptote is 0, your end behavior is 0 too. The green stuff goes together. This line is going to make the graph level off in these areas. Y-intercept, 4 times 0 plus 12 over 0 squared minus 9. You could call that like -1.33, or you could leave it as -1/3. And that's a point on the graph. X-intercepts happen when numerators are equal to 0, but holes can't be intercepts. So I only have an x plus 3 up top, but I already used that. It's not going to cross the x-axis, and that's because there's a horizontal asymptote there. So that's an NA. You're not going to see me plot what I've done. From here, you kind of can get an idea of what the graph looks like, but you don't have to, okay? You can type it in your calculator. I recommend not trusting yourself and typing it in your calculator to be sure. So if I want to get the mins and maxes and stuff, I'm going to use my graphing calculator. So in my numerator, I'll do a 4x plus 12. And in my denominator, an x squared minus 9. This gives me that shape. What this is going to tell me is there's no use. So for my mins and maxes, I'm just going to put NA. It's also going to give me a general idea of how to sketch this graph. Okay, so terms of sketching this graph, we saw that it kind of looks like that. It doesn't go through the hole, it goes through the intercept though, so it just takes kind of a momentary break at that hole. Because there's no mins or maxes, my increasing and decreasing should end up matching the domain's intervals, because we're using x values. So think about if you were to start walking right here, it almost looks like a flat hill, but it's slowly decreasing. So from here to the hole where it takes a break, this is a decreasing interval. It's not technically decreasing at the hole because it stops for a second. So like if you're walking, you take a pause. So that interval is a decreasing interval. It's from negative infinity to the x value of the hole, which is negative 3. We're using the x values. Then from here to here, it's also going down. So that's the x value of the hole, negative 3, to the x value of the vertical asymptote, positive 3. So if you look at the domain, that's that middle interval. And then from this part of the graph, it's also going down. So from here to here, this is another decrease. That's the x value of the vertical asymptote 3 off of the grid, infinity. So there's no increasing happening. And so that's going to leave us with the range. When you think of the range, I want you to take 3 things into account. 1, horizontal asymptotes. That 0 is going to make the graph pause at 0. That's going to affect the graph. 2, mins and maxes could create a minimum, which is like the lowest point of the graph, so I don't get to negative infinity. Or a maximum, I couldn't get to positive infinity. So those might affect the domain and range. I don't have that. And then holes do affect the domain and range too, because for a moment in time, the graph stops. And I have to take that into consideration. So, for my range, I start down here. There's graph down here. Down here is called negative infinity. And then the graph goes up, and it takes a brief pause at the hole. And range is y values. So this is negative infinity to the y value of the hole, which is negative 2/3. It's really small, but there's a stop there. And then it picks up again right there and then stops again. So that second interval of my range is really small. It's negative 2/3 to 0. Because then it's got that asymptote where it stops again. So it goes from this little section from the hole to the asymptote, and then it picks up again after the asymptote and goes off the grid. The whole part makes this confusing because otherwise it would look the same as the last one, but you have to have that break at the hole. So you're taking into account the horizontal asymptote, so you'll see 0 in there, and the y value of the hole, so you see the negative 2/3. Negative infinity to negative 2/3. Negative 2/3 to 0. 0 to infinity. All right, so you guys are going to try the next one. It's really similar to one of the 2 that we just did together. So see if you can go through and get through the pieces of that. If you can't get through something, then just skip it and wait till we go over it. But get through as much of it as you can. All right, tell me what you think about this domain. X can't be 1/2 and x can't be 1. So I'm going to do negative infinity to 1/2, 1/2 to 1, 1 to infinity. Anybody have questions on the domain? Domain's happening pre-canceling anything out. It's still a restriction if it cancels out. Okay, from here, I notice that something does cancel out. It's a -1, so there's going to be a hole at +1. So 6x plus 1 over 2x minus 1. And if I plug 1 into that, I get 7 over 1. So there is a hole at 1, 7. Holes aren't vertical asymptotes, so even though there's 2 denominators that I technically would set equal to 0, I'm not going to do that one because a hole doesn't count as a vertical asymptote. It's a part of the graph as a whole. So the only vertical asymptote here is coming in at 1/2. Somewhere in between 0 and 1. This one, 6x squared over 2x squared is 6 over 2, which is a horizontal asymptote at 3. And if you have a horizontal asymptote, you don't have a slant. If you have a horizontal asymptote at 3, you've got end behavior at 3 too. Anybody have questions so far? All right, so y-intercept, 6 times 0 squared minus 5 times 0, all of that's 0. So I end up with -1 over 2 times 0 squared minus 3 times 0, all of that 0. So I have a y-intercept at -1. So on the y-axis, it's hitting at -1. For the x-intercept, I normally would set your 2 factors in the numerator equal to 0, but a hole is not an x-intercept, so I'm not going to do that one. So I'll just have a -1/6, 0. Just like really, really close to 0. So those are those 2 points. That takes care of all the stuff that we did last week. So everything left is highlighted because that's new to today. My recommendation from this point is to go to your calculator, type in the equation, hit graph, look for a U shape. You can see from this picture that there's no U shape. So in terms of mins and maxes, I don't have any because there's no U shape. In terms of what my graph actually looks like, now I can connect some of this. The black is a momentary pause, or sorry, the hole is a momentary pause, so I'm not going to go through that, I'm going to leave that open. Increasing, decreasing, starting here, I'm walking down. So from here to here is a decreasing interval. That decreasing interval is -infinity to the asymptote, which is 1/2. Then very, very short interval from here to here, right? Because there's a momentary stop at that hole. So this is another decrease. It's just a really small decrease, which is the 1/2 to 1. I'm using my domain. You can see these are, sorry. You can see that these values that I'm writing down are from the domain. And then right after the hole off the grid is my 1 to infinity, and that's another decrease, because if I started here, I'd be walking down a hill. So 1 to infinity, meaning there's no increasing intervals here. That's new for today. Does anybody have questions on that? I'm using the x values, not the y values. range starting at the bottom, it goes up, up, and then what happens as I go up is it levels off and it takes this break right here. Nothing's happening at this green line. So the break is happening at 3. So the first interval of my range is negative infinity till I take that pause at 3. That's this part. Because I'm taking a pause, I can give myself a U there. And then right over the other side, not at 3, but right after 3, which is why I'm using a parenthesis, it picks up again. And it increases until it hits this breaking point, which is my hole, where it's stopping. And because it's the range, we're using the Y value of the hole, so it's stopping at 7. So this second interval is 3 to 7. If that hole wasn't there, it would just be 3 to infinity. But there's a break at 7. And then it picks right up again after the 7 and goes on to infinity. And so that's the range of this one. What do we think? Are we okay with that now that you've done one similar? Okay, I wanted to do just one more type. Normally I would not do this one today, but I am out Wednesday. I'm at a conference, so I'm trying to like double up these next 2 days because I won't be here Wednesday. So Wednesday and Thursday will both be test review days. So I just got to make sure I get it all in before then. So I want to do this one last example with you before you head out. This one has a slant. That's what makes it a little different. Okay, so all the process is the same. It's just when you go to do the range, it's going to be a little different because think about it. Like when we did those last 2 problems, the range was coming from the horizontal asymptote, right? The 3 was in the range. This one doesn't have a horizontal asymptote. It has a slant. So the range is going to look a little different. In terms of like factoring, I'm just factoring it really quick here. That's what I get. And so my domain restriction is that I can't have a -2, right? Because the denominator can't be 0. So I've got negative infinity to -2, -2 to infinity. Only one domain restriction. Because none of those factors match up, we don't have to worry about a hole. And so we have the vertical asymptote coming from the +2. All of those things tie together, and so I'm going to have this vertical asymptote at -2. The horizontal asymptote is where it gets a little trickier here because, again, this one has a slant. The top is a quadratic and the bottom is linear. So you have to do synthetic division to get this equation. We're doing synthetic division on the coefficients of the first 2 numbers. The third number is just a remainder. So I don't have a horizontal asymptote. I have a slant at y equals, it's not 1, it's some number x plus some number. So it'll be like 1x plus 0, which is really just x. So it would be x plus 0 if that helps you see that we are using the 0. So the y-intercept is 0 and the slope is 1. So I'm just going up on a diagonal by 1. And I'm making all of these points to serve as like my dotted line. And I'm going to do them through the whole duration of the graph because it is an asymptote. If you have a horizontal asymptote, your end behavior is really easy. Like a horizontal asymptote of 3 has an end behavior of 3. A horizontal asymptote of 0 has an end behavior of 0. A horizontal asymptote is easy for end behavior, but a slant isn't a number. Okay? When you have a slant, your end behavior is infinities. You just have to figure out which infinities. So look at this line. Right? This is the slant we just plotted. The left-hand part of this line would continue to go down if I continued to sketch it. So the left-hand end behavior is negative infinity, whereas the right-hand part of the graph would go up if I continued to sketch it. Most of the time, your end behaviors for a slant are negative infinity and positive infinity. Can anybody think of an instance when it would be the other way around?
You have a negative slant.
If you have a negative slope, a negative slant, if the slant was going this way, then it's positive infinity and negative infinity. Okay, so it just depends on like that slope of the slant, but if you gotta guess, this is a really good guess for a slant. All right, the negative infinity and the positive infinity. Intercepts, I'm gonna plug my zeros in. I end up with 0 squared plus 2 times 0, so negative 3 over 0 plus 2. Negative 1.5. And my x-intercepts are coming from setting my numerator equal to 0, and because there aren't any holes, that means both of the numerator factors are intercepts. So there are 2 of them. Negative 3 and positive 1. That's all the stuff that we've done so far. From here, for the U-shaped part of the graph, I recommend typing it into your calculator. Okay, so I did that to spare us the time. Here's this graph. Okay. So, in a sketch, that's what this graph looks like. No U-shapes. So because there's no U-shapes for the min and max, we're just going to go with NA. Tomorrow we'll start bringing in things that actually have mins and maxes. So my increasing and decreasing is coming from starting here, and you'd be walking up. So from here to here, this is an increase. Right, this graph is going up until it's not anymore. It takes a break, okay? So increase would be negative infinity to that negative 2. We're using the domain intervals. And then from here, start from this point, and you're walking up again. So this is another increase on negative 2 to infinity. Which means there's no point in time where this graph is decreasing. There's no horizontal asymptote, okay? So this graph, there's black, there's black, there's black, there's black. You might think it pauses here, but look over here. There's black in that spot too, right? So it just never stops up and down. Negative infinity to positive infinity. When there's no asymptote, horizontal asymptote to make it break, then it's negative infinity to positive infinity. You're looking for 3 things. Holes, there aren't any. Horizontal asymptotes, there aren't any. Mins and maxes, there aren't any. If you don't have those things, then you're not going to have anything funky happening to your range. I don't have any of those things here, so this would just be a negative infinity to positive infinity. All right? If you're looking for additional practice for this stuff, just because you want to keep up with it for your test this week, your practice would be workbook page 15, 1 and 2, keys on canvas. This is your optional homework that we've talked about. The answer keys on canvas. Explanations are on canvas if you need them. All right. Tomorrow we will do similar stuff, but with different types of graphs. They won't look like that, so the range will be a little different. And then, like I said, I'm out Wednesday, so I'm just going to leave practice. And then Friday will be a review day as well. And then, Thursday will be a review day as well, and Friday's your test. After your test,